Yeah, I'm totally ready. Okay, don't forget that the math learning project activity number 1 is due today if you haven't done it. I think like
That's the survey?
18 or 20, that's just that survey, yeah.
Okay.
Yeah, like 18 or 20 of you have already done it, so you're doing great. And then activity homework 3, the derivative is due Friday. So today we're going to expand on those definitions that we did on Monday, where we took the slopes of the secant lines in 2 different forms and took their limits to get the slopes of the tangent lines, right? So the 2 definitions that we used were, we used f of a plus h minus f of a over h. And which limit did we take in this case? H approaches 0. Yeah, limit as h approaches 0. So we said, let this point a plus h get closer and closer to that point we care about, a. So the distance between the 2 points got smaller and smaller and smaller. The other one we did was f of x minus f of a over x minus a. And this is the one where we let x get close to a. So those were the 2 definition of the derivative at one single point. And the point we were considering in both of these cases was that point A, right? We were doing it at f of x equals 1, or at x equals 10, or at x equals -1. Those were the places we were doing it. Today, what we want to talk about is if you have an entire function and you don't want to do this computation every time you have a new x value. So for instance, if they ask you, what's the rate of change at x equals 1? What's the rate of change at x equals 10? What's the rate of change at x equals -5? I don't want to have to compute these limits over and over and over again, right? What I would like is a new function called the derivative, which lets me just plug in an x value to find the rate of change. And so I do that again by taking a limit. And so the limit that I'm going to do is the limit as h approaches 0. Instead of putting in a particular value of a, I'm going to say do it for any x value. So notice the only difference between this limit and the ones we used on Monday is I'm not specifying which value of x I'm looking at. On Monday, we said x is 1. So we plugged in 1 plus h and 1. Or x is 7. We plugged in 7 plus h and 7. Today, we're not specifying which value of x we're looking at. We're saying for any value of x, what would this limit be? That will give me a function in terms of x. So notice when I did it on Monday, I got a value, a number, right? It was the slope. The slope was -1, or the slope was 7, or the slope was 8. I got a number out. When I do it this way, I'm going to get a function out. It's going to be an expression in terms of x, okay? It's going to be a value, a whole expression. If I want to find the slope at x equals 1, I'm going to take that expression, I'm going to plug 1 in. If I want to find the slope at x equals 0, I'm going to take that expression, I'm going to plug 0 in. Okay, so we're going to practice with this definition. This piece here, this f of x plus h minus f of x over h is called the difference quotient. It's what I showed you on Monday in D2L, where there's that boot camp on computing the difference quotient. That piece right there is called the difference quotient. What you do is you find this difference quotient, you simplify it so that that h in the denominator goes away. Because remember, in the end, you want to be able to plug in 0 for h. If that h in the denominator is still there, you won't be able to plug in 0 because it'll be divided by 0 and that would be bad. So we're going to find this expression, f of x plus h minus f of x divided by h. We're going to use algebra, bless you, simplify it, and then take the limit as h goes to 0. What we end up with should be a function in terms of x. Okay, what we end up with at the end should be a function in terms of x. Okay, so we're going to try it. We're going to do these 2 functions. This guy says f of x is 2x squared minus 7x plus 1. What we're aiming to find is a function that's the derivative of this guy So that if I want to know the slope at 1, I would plug it into that function. If I want to know the slope at -10, I would plug it into that function. I won't have to do those limits over and over again. Okay, I'm going to do it in pieces. And I like to do it in pieces because I don't want to make any mistakes. So I'm going to start, if you kind of think about this difference quotient as having 3 pieces. My first piece is going to be to compute f of x plus h. My second piece is going to be to do f of x plus h minus f of x divided by h. And my third piece is going to be to do the limit. Okay, so I'm going to go in pieces. I'm going to go step by step. First, I'm going to compute f of x plus h because that's the hardest part usually. So first, I'm going to compute f of x plus h. Then I'm going to try to do that f of x plus h minus f of x divided by h thing. Then I'm going to take the limit. So let's try it. Step number 1. F of x plus h. Here's my function. 2x squared minus 7x plus 1. How do I compute f of x plus h if that's my function? Yeah, plug x plus h in for all the x's, right? I'm going to have to replace this first x with an x plus h. I'm going to have to replace this second x with an x plus h. Everywhere I see an x, I'm replacing it with an x plus h. So I'm going to do 2 times x plus h squared minus 7 times x plus h plus 1. Okay, I'm going to do some simplifying. I'm going to distribute that 7. And then how do I do x plus h squared? Yeah, FOIL it out, right? If I want to do x plus h squared, I have to do x plus h times x plus h. So x times x makes x squared. X times h makes xh. H times x makes hx. And h times h makes h squared. I can simplify inside the parentheses first, or I can distribute the 2, whichever order you want to do it. Notice that these 2 terms in the middle are both the same. So x times h and h times x are both the same. So I have 2 hx's. And distribute that 2. So 2x squared plus 4xh plus 2h squared. Remember that minus 7 went with both pieces. So minus 7x minus 7h plus 1. So you can see that a lot of times this f of x plus h part is complicated, right? That's why I sort of do it as a first step all by itself. Because now I'm going to plug into that difference quotient formula. F of x plus h minus f of x divided by h. This whole piece right here goes in for f of x plus h. All of that stuff goes in for f of x plus h. So 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 1. Okay, minus. What do I put in for f of x? Well, f of x was, yeah, that original equation, right? F of x was that original equation that we started with right here. 2x squared minus 7x plus 1. So here I'm going to put 2x squared minus 7x plus 1. All divided by h. Okay, here's a hint. When you do this part here, at this step, every term that doesn't have an h in it should hopefully cancel. So what you notice is that we have a 2x squared in the first term minus a 2x squared in the second term. Those are going to cancel, yeah? We have a negative 7x in the first term minus a negative 7x in the second term. Those are going to cancel. We have a 1 in the first term minus a 1 in the second term. Those are going to cancel. So every term that doesn't have an h in it should cancel out. So in the numerator, I have 4xh plus 2h squared minus 7h divided by h. If they don't all cancel out, then you made an error somewhere, okay? So if you get to this step where you think you've done your simplifying and everybody doesn't have an h, then you made an error. The reason for that is I'm trying to get rid of this h in the bottom, right? To get rid of that h in the bottom, I need everybody in the top to have an h. So now I can take one h away from everybody. So I take the h away from here. I take one of the h's away from here, and I take the h away from there. Kind of like factoring it out, right? If you want to think about factoring out the h. Okay, so I have 4x plus 2h minus 7. What was step number 3? Do you remember? Limit. Limit as h approaches 0. Step number 3 is to take the limit as h approaches 0 of this guy. So for this h term, I'm going to plug in a 0. Not for any of the x's, right? I'm only taking the limit as h approaches 0. I'm not doing anything to the x's. Because remember, at the end, your answer is supposed to be a function of x. So there might be x's left in your answer at the end. So if you plug 0 in there for h, you're going to get 4x minus 7. Yeah. No, it says we have to plug in h for 0. It doesn't tell us that in the question. It says find the derivative using the definition. And this is the definition right here. So that says take limit as h approaches 0 of this thing. Yeah. Welcome. Okay, so what we got was that this derivative function is going to be 4x minus 7. Okay, I'm going to do the same thing again with this new function, 1 over x squared. Okay, so I'll use the same rules with this new function, 1 over x squared. I want to find the derivative. You could think of this as f of x if you'd rather. F of x is 1 over x squared. I want to find f prime of x, the derivative at any point x. How do I start? Yeah, find f of x plus h. Perfect. So 1 over x plus h squared. I'm not going to do anything to that. I'm just going to leave it like 1 over x plus h squared. It doesn't really help me to simplify that at all. So I'm going to leave it just like that. Okay, step number 2 is to do f of x plus h minus f of x divided by h. So f of x plus h is that thing we just found, 1 over x squared, 1 over x plus h squared. F of x is the original function, and I'm going to simplify. So I have 1 over x plus h squared minus 1 over x squared divided by h. Uh-oh. This is bad news. No, it didn't work. I'm gonna just write it again. Okay, f of x plus h was 1 over x plus h squared, step number 1. Step number 2 is f of x plus h minus f of x over h. So 1 over x plus h squared minus 1 over x squared divided by h. Okay, let me make a note up here. See next page. Okay, how am I going to simplify this guy, you think? Because remember, when I'm simplifying this thing called the difference quotient, what's my goal? Get that h out of the denominator, right? So how do you think I'm going to simplify this guy? Make a what? Combine the fractions together, yeah? Yeah, I will eventually times it by h over 1, well, by 1 over h though, right? Because this is h over 1 right now. And so I would times it by 1 over h and it would still be in the denominator. So I'm going to combine the two fractions together. To combine two fractions, I need a common denominator. In this case, I'm going to make my common denominator x plus h squared times x squared. So I'm going to multiply every term by x plus h squared times x squared, including the denominator. Okay, I'm multiplying every term of my equation by that thing. In the first term, the x plus h squareds cancel out. So I'm left with x squared. In the second term, the x squareds cancel out. So I'm left with x plus h squared. In the denominator, I have h times x plus h squared times x squared. Okay. What do you think now? Yeah, let's FOIL that out. Let's multiply out that x plus h squared. So I have to do x plus h times x plus h. You're going to do this x plus h squared thing a whole bunch. So eventually you'll just memorize what x plus h squared is. X squared minus. Notice I'm keeping those parentheses around, right? Because everybody in this second term after I FOIL gets subtracted. Okay, x times x makes x squared. X times h and h times x are the same. I get 2 of those plus h squareds over h times x plus h squared times x squared. This minus sign goes with every piece here. So I have x squared minus x squared minus 2xh minus h squared divided by this, h x plus h squared, x squared. All right, now what? Cancel those x squareds. That's a good idea. Let's cancel those x squareds. There's a lot of algebra, right? Hopefully we're going to not have to do this forever. Turns out we only have to do it till Monday, so you're fine. Spoiler alert. Yeah, now I'm going to cancel out an h. Notice that this guy down here in the denominator is just one single term, right? A whole bunch of things multiplied together is just one single term. So I'm just going to cancel the 1h from the denominator. I'm going to cancel an h from this first term and 1h from that second term. So I'm going to take an h away from everybody. 1 from here, 1 from there, and 1 from there. When I do that, I have negative 2x minus h divided by x plus h squared times x squared. Yes, sir. Want me to go up some?
Yeah.
More? Okay. Yes. Because I had an x squared minus an x squared, so they go away. Yeah. Remember, when I get to that step, everybody without an h should hopefully cancel out. So that it worked out there. All right, what's the last step? Find the limit as h approaches 0. Find the limit as h approaches 0, which means to do what? Plug in 0 into this equation for all of the h's. So I'm going to plug in 0 for all of the h's. So those two h's are going to go to 0. So in the top, I'm going to have negative 2x. In the bottom, I'm going to have, what's x plus 0? X squared times x squared. X to the 4th. Okay, let's do a little simplifying. X to the 4th. Then I have an x on the top and an x to the 4th on the bottom. Negative 2 over x to the 3rd. So I plugged in 0 for all the h's, right? When I do something minus 0, I just get negative 2x. X plus 0 makes x. I have that square on it. So I have x squared. I have this other x squared. So that's there too. X squared times x squared makes x to the 4th. If I have an x on the top and 4 x's on the bottom, I can cancel and be left with 3 x's on the bottom. So negative 2 over x cubed. That is the derivative of this function at any x value, right? Except which one? 0. I can't use 0 in this guy because 0 in the denominator should be the flashy lights, right? Okay, so let me scroll up and write what we got. We said y prime or f prime of x is going to be negative 2 over x cubed. So if I want to find the slope of the tangent line to this function at x equals 7, I could just plug 7 into that equation. If I want to find the slope of the tangent line to this function at x equals negative 2, I can just plug negative 2 into that equation, right? So once I have a derivative equation or a derivative function, instead of just a slope of a tangent line, I can find the slopes at many, many places easily. Okay, here's what we're going to do. I have 6 problems. I'm going to pause the video. We're going to do some board work. Pause. Resume. Specifically, tell me, before you did any of the rules, what did you tell me about number 6?
Well, it doesn't have an x.
It doesn't have an x. What does its graph look like? It's a flat line, right? So before you even started, you said to me, I think the derivative is going to be 0. Because number 6, if you think about the graph of number 6, it's a horizontal line, right? At every value of x, the graph is a horizontal line. What's the slope of a horizontal line? 0. Yeah? Okay, group number 3. It was you guys in the back, right? You guys were 3? Tell me about your function. Group number 3 had this function, negative x minus 5. What kind of picture does negative x minus 5 have? A straight line going down. What's the slope of negative x minus 5? Negative 1 at any value of x, right? No matter which value of x you pick, the slope is negative 1. What should their derivative be? Negative 1. Their derivative does not depend on x. Everybody else has a function whose slope, no, I'm sorry, number 2. Who's group number 2? Over there. You guys have what kind of line?
A straight line.
Your derivative is a straight line. Your function is a line going down with a slope of negative 2. No matter which x value you pick, the slope is going to be exactly the same, always negative 2. These 3 functions, 1, 4, and 5, they change depending on the x value, right? In this x squared plus 1, x squared plus 1 is a parabola that looks like this. At this point right here, the slope is definitely different than the slope right here. Definitely different than the slope right there, right? So when they find their derivative, it should be a function that depends on which x value they're at. So group number 5 found their derivative, and they said it's equal to 2x. So the value of the slope changes depending on which x value they're at. When they're in the negative x's, the slope's going to be negative. When they're at 0, the slope's going to be 0. When they're in the positive x's, the slope's going to be positive. Okay? So think about the graph. Sometimes it's the easiest way to answer the question. Okay, I'm going to put those 6 pictures up there so you can see them when you're practicing. Onward. Oh, found it. Okay, so this takes us to what does the derivative tell us? So when we defined the derivative, we said the derivative is the, what does it mean? Slope of the tangent line. The derivative is the slope of the tangent line. How fast the function changes at any particular point, AKA the rate of change. Okay, if I tell you that the derivative is a positive number, if I tell you that the derivative is a positive number, what would you tell me is happening to the function? It's going up, right? In math terms, what do we say it means when it's going up? Increasing, yeah, that's how you said. Yeah, that's what you said. When f of x is increasing or going up. Okay. How about when the derivative is a negative number? It's going down. The function is decreasing. These go both ways. If you have a function and it's decreasing, your derivative is going to be negative. If you have a derivative that's negative, your function is going to be decreasing there. Okay, so these go in both directions, going down. Okay, the only number I didn't consider is what happens when the derivative is 0. It's like a flat point, right? Like the tricky part is like the derivative is 0 a lot of places and where it doesn't like look like a constant function. Okay, so these are flat points, let's call them, but I'm going to put that in parentheses. I'm sorry, in quotation marks. Really what you're going to think about is it could be flat like this. It could be up here at the top of a hill or down here at the bottom of a hill. You see at the top of a hill or the bottom of a hill right there, it changes from increasing to decreasing or decreasing to increasing. If you change from increasing a positive derivative to decreasing a negative derivative, you have to go through 0 to get there, right? If you change from decreasing a negative derivative to increasing a positive derivative, you have to go through 0 to get there. So at the tops and bottoms of hills, the derivative is going to be 0, okay? Just for that one instant, right there at the top, right there at the bottom. To the left and right of that, it's not, right? Right here, the derivative is a negative number. Right here, the derivative is a positive number. But at the tops and bottom of hills, the derivative is going to be 0.
Flat one?
Like I said, flat point, but I don't want you to just think of it about getting flat. It doesn't have to be totally flat like this. It could just be like the top of the mountain or the bottom of a valley. That's why I quotation marked it. So let me say top. Yeah, this pencil is terrible. Top and bottom of hill. I went home last night and I was like, I need an Apple, an iPad Pro and an Apple Pencil for my birthday. My kids were like, yeah, sure you do, Mommy. You'll see. My birthday's in September. Let's see if I get one or not. If I come back after my birthday with one, I'll be like, yep, it worked. Okay, so here is a function. Boom. I don't know anything about it. I don't know its equation at all. I just know its picture, right? It says, at which points is the instantaneous rate of change? What else can we call the instantaneous rate of change? The slope, the derivative. Yeah, those are all great words. The slope or the derivative. Slope, derivative. At which points is the instantaneous rate of change of the curve negative? So here are 5 points, A, B, C, D, and E. Where would you say that the instantaneous rate of change is negative? Yeah, D and E. At those 2 points where the graph is going down. D and E going down. Decreasing. Yeah. At which points is the instantaneous rate of change of the curve positive? Yeah, the other 3, A, B, and C, where it's going up. Okay, that was the easy part. Going up. Part C says, list the slopes in decreasing order. So I want to put the biggest numbers over here and the smallest numbers over there. I have to be a little bit careful because when I talk about negative numbers, -1 is bigger than -10. Agree? -1 is bigger than -10. Because on a number line, -1 is here and -10 is there. So -1 is bigger than -10. So if you had to estimate these numbers, right? Would you say A is a big number? Well, what kind of number is A? Positive or negative? Positive. A is positive because the graph's going up there. Would you say it's a big positive number or kind of small near 0? Kind of small near 0, right? It's not going up very fast there. How about B? Bigger, yeah? How about C? Smaller. If I'm drawing tangent lines there, right? If I draw a tangent line here at A, and I draw a tangent line at C, do you see that A has a slightly bigger slope than C does? And B has the biggest one, like that's going up the fastest. So we're going to put B here. It's going up the fastest. And then which one are you going to put next? A, and then C. Yeah. B is going up the fastest. That's where it's increasing the fastest. It's scooching up as high as it can. A seems to be a little bit bigger than C. We could have a little debate, right? They seem pretty close to one another, but we'll go with A being a little bit bigger than C. Okay, now comes the hard part, D and E. Let me draw some lines there. Here's the slope at D. And here's the slope at E. If I'm going to label, that's a terrible one. There's the slope at E. If I'm going to label the slope at E, I'm going to call it like -1. If I'm going to label the slope at D, what would you call it? Like -3, yeah? So if I'm going from big numbers to small numbers, I have BAC, then comes 0. Which of these numbers comes next? -1, E, and then D, -3. Even though D is going down faster than E, right? So in absolute value, if we didn't care which direction it was traveling, then in absolute value, the car at D is going faster than the car at E. Yeah, if you're rolling down the hill in your dirt bike or whatever, you're going faster at D than you are at E. You started slowing down at E. Yes, but -3 is a smaller number than -1. That's really hard. It's hard to remember that we care about the number line and where the numbers go. I was like, okay, so let's talk a little bit more about interpreting. What does the derivative tell you again? Slope, otherwise known as instantaneous rate of change, how fast something is changing, right? It's a slope. When I'm interpreting the slope, it should have the word per in it, right? When I write the units, it should say dollars per month or cows per ounce of milk, right? It should, or maybe ounces of milk per cow would be a better unit. It should have some word per in it because it's change in Y over change in X. If F represents how many meters you have run, and X represents the minutes. describe in full sentences the following. So F is a function that tells you how many meters you have run in X minutes. So over here, it says F of 8 equals 1,500. What does that say? You ran 1,500 meters in 8 minutes. You ran 1,500 meters in 8 minutes. It's pretty fast. It's faster than I run. Probably not faster than you guys run, because you're a lot younger than I am. You ran 1,500 meters, because that's my output. You ran 1,500 meters in 8 minutes. 1,500 meters is like almost a mile. Those Olympic marathon runners, did anybody watch that Olympic marathon? That dude is like a beast. That's all I'm saying. They're running like 5-minute miles. So they're running like 1,500 meters in 5 minutes for 26 miles. Like, okay, what does this guy say? What's different about this one than this one? It has that prime, right? It has that derivative symbol, yeah? So it's the slope. It's telling you your rate of change or how fast you're going, right? When? At exactly that 3-minute interval, right? So like somebody's watching you run. When you hit 3 minutes, they take a snapshot and they say, right now at this 3-minute mark, you are running 161 meters per minute, right? So just per minute, right at that one instant. So at the time, 3 minutes. At the instant after you've run 3 minutes. Doesn't tell me how fast I'm running before that. Doesn't tell me how fast I'm running after that. Right there at the 3-minute mark, you are running at a rate of 161 Y's, meters, per X's, minutes. So at the 3-minute mark, you are running at a rate of 161 meters per minute. So like you're running along, you're 3 minutes into your run, you look at your watch, it says right now this is what your speed is. Okay, 161 meters per minute. So you have to remember that a derivative has to tell you a rate. It has to tell you how fast something's changing. It could be how fast your position is changing. It could be how fast your money is changing. It has to tell you how fast something is changing. Okay, one more. I'm gonna have to put this on another page. Apparently right there. I'm gonna put it on another page. The population of a slowly growing bacterial colony after T hours is given by P of T equals 3T squared plus 29T plus 200. So the population is given by that function. Find the growth rate after 3 hours. What do they want you to find? P prime of 3. They want you to find P prime of 3. We can do this 2 ways. We can do this with the stuff we used on Monday, right? Because I only care about the rate right at time equals 3. So we can use this with one of these 2 formulas, whichever one you like, that we did on Monday. Or we can use the new formula today that finds us the derivative at any point, and then plug in 3. Okay, either of those options are going to work because they only care about that 1.3 hours. So you can use the things we did on Monday where A is 3, or you can use the new thing today, find it for any value of T, and then plug 3 in at the end. Let's do a little bit more practice with what we did today. So I'm going to do one more. How do I start? Do you remember?
Yes.
f of x plus h, right? This is going to be p of t plus h. It's really tricky because I use different letters on you. So I replace all of those t's with t plus h's. Okay. Okay, I have to do t plus h squared. When I do t plus h squared, I'm going to get t squared plus 2th plus h squared. Because I'm going to do t times t times h times t, h times h. Okay, I'm going to distribute the 3. 6th, 3h squared, 29t, 29h, 200. Absolutely.
At the very top.
The very top, absolutely. Okay, what's the second step? Right. Absolutely. So I need this guy that I just computed. I need my original function up here, and I'm going to divide it by h. Okay, I have to write tiny. 3t squared, 6th, 3h squared, 29t, 29h plus 200 minus the pink function, 3t squared, 29t plus 200, all divided by h. Your hope is that all of the pieces, the 3t squareds, the 29t's, and the 200s cancel out, and everybody that remains has an h. So I have 6th, 3h squared, 29h. What do you think I should do now? Cancel out an h. Yeah, I got an h in everybody. Well, everybody has an h in it. So I'm going to take one h from every term. So I get 6t plus 3h plus 29. Okay, last piece. Find the limit. Which limit? As h approaches 0. Okay, so 6t plus 3h plus 29. I want this guy to go to 0. So I get 6t plus 29. Is that the answer? No, right? Yeah, so this is p prime of t, 6t plus 29. That's p prime of t, 6t plus 29. I gotta take it, and I wanted to find, I don't want to scroll till people are ready though. I've learned in 15 years of teaching that I write fast. You agree? I don't know why, just is what it is. Okay, up here it said, find the growth rate after 3 hours. So we said we should find the derivative and plug in 3. So I'm going to take 3 and plug it into this function. P prime of 3 is 6 times 3 plus 29. 18 plus 29 is 47. Can you tell me what the units on that thing are? Let's go back to the question. The population of a slowly growing bacteria colony after T hours is given by blah, right? So the population of a slowly growing bacterial colony after T hours is given by that. So we found that P prime of 3 is 47. What would your sentence say? After 3 hours, the bacteria are growing at a rate of 47 bacteria per hour. Yeah. At the 3 hour mark. Oh my God. At the 3 hour mark, bacteria are growing at a rate of 47 bacteria per hour. It's going to be some moldy bread. That's all I'm saying. Okay. One Edfinity question. I had 2 people ask me, so let me do one Edfinity question, and then we will be done with our day. Don't forget that your that learning project thing is due today. If you haven't done that yet, do that learning project thing. Number 3. Is your name Christian? No. What's your name? What's your name? Yeah. Adrian. Who's Christian? Oh yeah. Okay. Number 4. Yeah. Number 4 is like the one we did at the start of class. I'm gonna do number 3, and then I think we'll have time for number 4 as well. Insert pages. I'm going to tell you right now that you don't want to wait until Friday night to start your homework. Okay, this guy says use this definition, limit as x approaches a, f of x minus f of a divided by x minus a to find the slope of the tangent line at a equals 3. Okay, so I want to find the slope of the tangent line at a equals 3. So I have to do limit as x approaches 3, f of x minus f of 3 over x minus 3. Okay, f of x is this function. So 4x squared minus 2x plus 8 minus, whoops, put my limit in there. F of 3, to find f of 3, I got to plug 3 in. 4 times 3 squared minus 2 times 3 plus 8 gives me, let's see, 9 times 4 is 36, minus 6 is 30, plus 8 is 38. Yeah, okay. Equals, limit x approaches 3, 4x squared minus 2x minus 30 over x minus 3. Now what? Adrian's was a lot easier to factor than this one. You got an easier evolution of the problem. Yeah, I got a factor, I think, right? If I'm going to factor, I would probably factor a 2 out first. 2 times 2x squared minus x minus 15 over x minus 3. I'm going to guess and check. I need a 2x and an x. I need to get to, yeah, okay, so -6, 3, and positive 5. So 2x times -3 makes -6, and then 5. If you are not an expert factorer, then guess and check is not your best method. Go back and practice factor by grouping, right? If you are not an expert factorer, guess and check could take you forever. Don't try it. Go back and use factor by grouping. Okay, why did I factor? So you could cancel out the x minus 3s because you want that guy from the denominator to go away. So I have 2 times 2x plus 5. I wrote that limit down the whole time because why? I want to be able to plug in 3 for x. So 6 plus 5 makes 11, times 2 makes 22. Okay, number 4. 4 gives me this function. And it wants me to use this definition. This one's hard. This is like the one we did at start of class, right? And it wants me to do it at a equals 3. Okay. So I'm going to do limit as x approaches 3, f of x minus f of 3 all over x minus 3. No, it doesn't. It says 1. Sorry, I read badly. It says 1, 1, 1. That's better. Okay, f of x is this guy. F of 1 is 4 over 1 squared, or 4. So I have limit as x approaches 1 of f of x, 4 over x squared, minus f of 1, 4, all divided by x minus 1. All right, what do you think? Yeah, make a common denominator. My common denominator, the only denominator that's there is x squared. So I'm going to multiply every term by x squared. When I multiply in the top, I get 4 minus 4x squared over x squared times x minus 1. This x minus 1 hasn't gone away yet, right? Like if that x minus 1 hasn't gone away yet, you're going to have to do some simplifying up here in the numerator. So what are you going to do? Take out a 4. Okay, that's a good start. 4 times 1 minus x squared. I'm doing well. I know. It's okay. It's going to be great. I can factor that guy into 1 minus x, 1 plus x. He's a difference of squares. Okay, these two guys, 1 minus x and x minus 1 are almost exactly the same, right? They're just in the wrong order. If you want to cancel things that are in the wrong order, what do you leave behind? A -1. If you cancel things that are in the wrong order, you leave behind a -1. So I'm going to cancel the 1 minus x and the x minus 1, but I'm going to leave behind a -1. If they were in the same order, when I cancel them, I just get a 1, right? But if they're in the wrong order and I want to cancel them, I can do it as long as I leave behind a -1. Okay, so I have limit as x goes to 1, -4, because I have a 4 and a -1, times 1 plus x over x squared. What's the last step? Plug in 1 for x. 1 plus 1 over 1 squared, -8. Okay, so my slope is going to be -8. Okay, tonight you have that math learning project thing to do. It takes like 5 minutes. It's super fast. Click, 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 click. Super fast. It gives you some code at the end. You got to enter that code. Friday night, your homework's due. Friday, we're going to do more interpreting and then differentiability. That's all we got left. See you Friday. Go get vaccinated. The last thing on campus is Friday. You can get $100.
Yeah, push button number 2. You want me to put on that?
No, it doesn't matter.